Episode 6, and the spine moves. Everything in the first 5 episodes was about managing memory, what to keep, how to organize it, who decides, and what happens as it ages. From here the subject changes. Now the agent itself is what gets modified, and memory becomes the substrate that makes the modification stick rather than the thing being managed. This episode is the map of that territory. It is a classification episode, which means it is deliberately light on results and heavy on structure, and I will be explicit about that rather than let it look like a gap in the evidence. And there is a real reason the two halves belong together, which slide 14 makes precise rather than gestural. Start by separating 3 things that share one word. First, better output this turn, the agent revises its own answer before you ever see it, and nothing persists afterwards. Second, better policy next week, experience from this task changes how the next task gets approached. Third, a different agent next month, where the scaffold or the tools or the weights are no longer what they were. 3 different clocks, 3 different kinds of evidence you could possibly collect, and one word covering all of it. Most disagreements about self-evolution turn out to be people using the term at different speeds. Getting the clock right before the argument starts saves more time than any technical point in this episode. 3 objectives. Place any self-improvement method on a 4-question grid. Distinguish refinement inside one episode from accumulation across episodes, and say why that distinction decides what evidence is even available to you. And read a skill library as a memory design, which is the bridge back to the first half of this series. One boundary, stated up front so you are not waiting for it, this episode is classification and loops. Workflow search is episode 7. Agents that rewrite their own code are episode 8. And the question this series is actually built around, how you know a change was an improvement, is episodes 9, 12 and 13. The frame for the episode is 4 questions. What is being modified? When does the modification happen? How is the modification derived? And where does it live? I want to be clear about what this grid is. It is our synthesis across the surveys in this episode, not a reproduction of any one of their taxonomies, and the on-screen attribution says so. Asked in that order, of any method you meet, these 4 are enough to place it. And the order matters, because the 4th question is the one people forget to ask, which is why 2 of the most interesting things in this episode are answers to it. First question, what gets modified? 6 targets, prompt, memory, tool set, workflow, weights, and harness, ordered roughly by how cheap each is to change and how hard each is to audit, which are not the same ordering, and that is the interesting part. Almost every published method touches exactly one of these, and I want to flag that as a fact about the literature rather than a fact about the problem, nobody is combining them yet. Memory sits second in that list, which is the reason the first 5 episodes were a prerequisite for this one and not a preamble to it. If you are choosing one target to work on, choose the one you can audit, not the one that is cheapest to change, those are usually different. Second question, when? In episode, inside a single task and before the answer is returned, seconds. Between episodes, from what the last task taught, hours to days. Or offline, in a separate training or search process, days to weeks. Notice that this slide has the same shape as slide 2, and that is deliberate. The 3 things people mean map onto the 3 times it can happen. The consequence is the part to carry forward. The clock you pick decides what evidence you can possibly have. An in-episode method can be checked against the answer it just produced. An offline one cannot be. That constraint is worth writing on a wall somewhere, because it rules out whole evaluation designs before you have built anything. Third question, how? Verbal feedback, a critique in natural language, carried forward into the next attempt. Search, propose candidates, evaluate them, keep the best. Text gradient updates, a critique used the way a gradient is used, which we met already in episode 4 and which episode 7 takes up properly. And reinforcement learning, a reward, and a policy that actually moves. They are ordered by how much signal each one needs, and if you read that as a ladder you can predict which methods will work in which domains before trying them. No system names on this slide, deliberately, those belong to episode 7. Notice also that the ladder runs from cheapest to most expensive, so the mechanism you can afford is rarely the one you want. Fourth question, where? A single agent that changes itself. A population, where many agents exist and what survives is what propagates. Or the environment, where the task distribution or the tooling changes and the agent follows it. That is the social reading of where, how many entities are involved and how they relate. It is the reading the surveys give, and it is a good one. But it is not the only reading of that question, and the other one turns out to matter more for anybody who has spent 5 episodes thinking about memory. So hold this slide, and let me put a second answer next to it. Here is the second reading. A change can live in a non-parametric store, an explicit buffer of compressed past trajectories, which is inspectable, editable and deletable. Or it can live in the parameters, compact, fast, and not inspectable at all. Episode 3 already made half of this point, that distinction is our 06 forms axis. What is new is not the two loci, it is the conversion. Our 10 puts the change in both places and runs it both ways, trajectories are compressed into the buffer retrains the planner, and once that internalization has happened the explicit entries are selectively cleared. Deletion becomes safe because the content moved rather than vanished, and that is the only principal deletion argument anywhere in this series so far. So here is the grid with 12 mechanisms placed on it. Watch the cells rather than the labels going by. 2 things become visible once they are all down. First, almost every method occupies exactly one option per question, one what, one when, one how, one where. It is a point on the grid, not a region, which tells you these are narrow interventions rather than programs. Second, and more usefully, most of the grid stays empty. Those empty cells are not gaps in the map. They are gaps in the literature, and a few of them are empty for good reasons while others are simply unexplored. If you take one habit from this episode, take the habit of asking which cell somebody is in before you evaluate their claim. The first family is verbal reinforcement. The agent attempts a task, fails, and then writes a critique of its own attempt in natural language. That critique goes into an episodic buffer and is carried into the next attempt. 3 components, an actor that acts, an evaluator that scores, and a self-reflection step that converts the score into text. No weights move at all, the improvement lives entirely in what gets put back into the context. And it works, 91% pass at 1 on human eval against 80 for the then state-of-the-art, plus 22 points absolute on ALF World over 12 iterative learning steps, and 20 points on Hot Pot QA. The second family closes the loop even tighter. Generate an output, have the same model critique it, revise, and repeat until a stopping rule fires. One model plays all 3 roles, with no supervised data, no additional training and no reinforcement learning. Roughly 20 points absolute on average over one-step generation across 7 tasks, with a range from 5 to 40 points depending on the task, and up to 13 on code generation. 2 things to notice. The range is wide, which means the average is doing a lot of work. And the stopping rule is the underspecified part, it is what decides whether this costs you 2 model calls or 10. Both of those methods depend on one thing, and it is worth laying out as a ladder. Top rung, a passing test, unambiguous, cheap to check, and only available where correctness is executable. Then a graded score, which needs a scorer you trust more than the thing being scored. Then a preference between 2 outputs, no absolute scale, but robust, and enough to rank. Then a critique in prose, rich, unverifiable, and in both of these methods it is the same model's opinion of its own work. And at the bottom, silence. Each rung down is cheaper to obtain and weaker to learn from, and both of the last 2 slides live on rung 4. Which brings the 2 clocks into one picture. 2 nested loops running at different speeds. The inner loop improves this answer and then discards everything it learned when the task ends. The outer loop writes something down, so the next task starts from a different place than it otherwise would. Watch the marks, the inner loops evaporate, the outer loops accumulate. And that is the sentence this whole series turns on. Only the outer loop accumulates, and only the outer loop needs memory. Refinement without memory is a better answer. Accumulation with memory is a better agent. Refinement without memory gives you a better answer. Accumulation with memory gives you a better agent. Those are different products, sold under one name, and evaluated with completely different instruments. The third family stores procedures rather than critiques. A skill here is code, not a description of code. It is stored, retrieved by task, and composed with other skills. And it is indexed by the embedding of its own description, so retrieval happens by intent rather than by name. 3 components: an automatic curriculum, an ever-growing skill library, and an iterative prompting loop with self-verification. The base model is queried as a black box and nothing is fine-tuned. Reported against the prior state-of-the-art, 3.3 times more unique items, 2.3 times the distance traveled, and key milestones reached up to 15.3 times faster. The curriculum is the part that makes it open-ended. Look at what the agent can already do, propose the next task just beyond that, attempt it, and on success the frontier moves outward. On failure, propose something nearer. Nothing here is given from outside, the curriculum is generated, and the agent's own competence is the only thing setting the difficulty. That is what makes it scale without a human in the loop. It is also the first appearance in this series of a problem that episode 9 is entirely about. Nothing outside the loop is checking that the frontier is moving in a useful direction rather than merely outward. And here is the mechanism that makes the library trustworthy. A new skill is proposed as code. It runs. Its self-verification either passes or it does not. Only on a pass does it enter the library and become available for composition with everything already there. Watch the rejected candidates, they leave no trace in the store at all. The gate is on the right, not on the read, and that placement is the entire difference between a library and a pile. Every memory design in the first 5 episodes let the write through and hoped the read would sort it out. Every memory design in the first 5 episodes let the write through and hoped the read would sort it out, and that is why their verification columns were empty. Now read that library back through episode 2, and something falls out. Write, add a skill, but only if its test passes. Index, by the embedding of the skill's own description. Retrieve, by task intent, at planning time. Update, revise a skill after a failure in the field. Forget, deprecate one that has been superseded. Consolidate, compose several into one higher-level skill. All 6 operations, present in one system, which is more than any architecture in episode 3 managed. And the write is gated by a test. Episode 2's verification column was almost empty. Here it is, the load-bearing column. Which makes this the moment where the 2 halves of the series actually meet rather than merely alternate. Step back to how the surveys frame all of this. The transition they describe is from a model that answers to a system that accumulates, and they converge on 2 components, a scaffold around the model, and an update operator that the system applies to itself. That framing has a consequence I think is underrated. The interesting object is not the model, it is the scaffold plus the operator. Which is why upgrading the base model and the agent improving are different claims, and why the second one requires an argument that the first one does not. 2 of the surveys here give 2-axis frameworks for that operator. That distinction between upgrading the substrate and improving the system is the one that most product claims blur, usually without meaning to. The first framework crosses what gets updated against what drives the update. Its 2 definitions are the useful part, and both are locked terms in this series glossary. The agent is a foundation model plus an operational scaffold, prompts, memory, tools, control logic. And self-improvement is a self-induced update operator applied either to that scaffold or to the weights. Both phrases are this survey's, not ours. What the grid buys you is a clean question to ask of any claim: which cell is this in? Because a human editing prompts and an agent editing its own prompts are the same target with a completely different accountability story. Ask that of any self-evolution claim you meet and roughly half of them turn out to be describing prompt engineering with a longer name. The second framework crosses something different. What the system improves, and there are 4 options, not 2, deployed behavior, the post-training policy, the evaluator, or the research process itself. That is crossed with how closed the loop is. And the distinction it draws along that axis is the one to remember: bounded self-refinement, where something outside the loop still checks, versus open-ended recursive self-improvement, where nothing does. Look at the bottom right cell, where a system improves its own evaluator with the loop fully closed. Everything in the second half of this series is about that cell. A system that improves the thing which judges whether it improved is a different animal from a system that improves its own answers, and the second half of this series is about not confusing the two. Put them side by side, because they get conflated and they should not be. The first asks what gets changed and what drives the change. The second asks what improves and how closed the loop is. The overlap is partial rather than total, and the gap is instructive. Self-driven and fully closed are close but not the same thing, because a self-driven update can still be reviewed before it takes effect. That difference is exactly where governance lives. This comparison is ours, neither survey sets its axes against the others, and the chart is deliberately not a reproduction of either one. Conflating the two frameworks is easy because both have 2 axes and both are drawn as squares. That is the entire reason this slide exists. The same survey names 3 failure modes, and it draws them from a corpus of 1,250 papers, which means these are observed patterns rather than speculation. Self-confirming loops: the system's own output becomes the evidence that its output is good. Episode 9 is entirely about that one. Model collapse: training on your own generations narrows what the model can produce, generation over generation. And diversity collapse: a population converges, keeps improving on the metric, and stops being able to surprise you. All 3 are failures of the loop rather than of the model, and none of them shows up as an error at the time it happens. Finally, a domain case, because it is the clearest available example of cross-episode accumulation with a real outcome attached. A simulated hospital in which patients, nurses and doctors are all model-driven agents. Doctor agents evolved by treating patient agents and by reading textbooks, using no manually labeled data, only synthetic data the simulacrum generates, with a quality control agent over it. 32 departments, 339 diseases, and accuracy that rises with the number of patients treated, up to 50,000. And one condition that has to travel with the headline: the reported gain is on respiratory disease questions, not on the whole benchmark. I am spending a slide on that condition rather than a footnote, because a subset result quoted as a whole benchmark result is exactly the failure this series was built to catch. So what is that experience worth? Some of it transfers. The procedure transfers: which examination to order and in what order. The shape of a differential diagnosis transfers. The habit of checking before concluding transfers. And some of it does not. The base rate does not, because how common a disease is in your population is not a property of the simulator. The failure distribution does not, so which mistakes are dangerous rather than merely wrong is not learned. And nothing the generator did not know it was encoding can come out. Experience grown in a simulator is experience about the simulator, a scope statement rather than a dismissal. Lab 6. Take your own agent and place it on all 4 questions: what, when, how, where. Then place every change you made to it in the last month on the same 4 questions, 1 row per change, for fields and no free text allowed. Then find the axis you never touch. Most teams have one, and in our experience it is where everything happens inside a single agent, at one locus, and nobody has considered the alternatives. The canvas is in the repository. This lab produces an uncomfortable list rather than a number, and the discomfort is the point. And once you can see it, the fix is usually cheap, because the untouched axis is untouched from habit rather than from analysis. 5 takeaways. 3 clocks share one word, so ask which one somebody means before arguing with them. For questions, place any method. Most methods are a single point on that grid, and most of the grid is empty. Only cross-episode loops accumulate, and only they need memory, which is why these two halves are one series. A skill library is a memory design with the verification column loaded, and it is the only design so far where a write must pass a test. And on the question this series exists for, the surveys answer what can change, and one of them locates the emptiest position itself, governance grade measurement of self-improvement. That lands in episodes 12 and 13.